So we learned yesterday how to solve a linear system. So basically two linear equations using graphing, right? So graph the first line, graph the second line, find a point where both lines intersect, okay? Today we're gonna learn how to do the same thing. So we're still finding the point of intersection, but we are finding it using a method called substitution, okay? What does the word substitution stand for? So when you're going and you're saying like, substitute this for this, what does that mean? Replace. Replace, okay? So let's say if you don't want the drink to have, let's say sugar, right? You say substitute with sugar-free this, right? So we're substituting, so we're replacing. So we're gonna do the same thing in here. We're gonna replace something for something else, but they have to have the same value. Okay, so let's look at this. Remember that the end, we are looking for a point of intersection. So we're looking for when do the two graphs meet. Okay, so we're solving for the system of equation using substitution, y equals negative 2x plus 1 and y equals x plus 7. Okay, so these are the two lines, right? I want you to look at something here. So if I'm looking at two lines, and I'm looking at this point of intersection, right? The y value for that point of intersection, right, is the same for both lines, yes? So the y value right here, so let's say if this is 1, 2, just to give it a number, right? Let's say if this is 1, 2, that 2 is for both lines, yes? Both lines are equal to 2 at this point, yes? And then both lines have the same x value, which is 1, yes? That's the only point that both lines have in common, which is 1, 2. Every other point, it's going to have a different value. Right? Every other point is not common between the two. The only common point is the point of intersection. Do you guys agree with that? Kind of lost. So, when are these two lines equal to each other? When are they equal to each other? At what point? When are they at the same place, the same spot? When they cross, right? They're at the same spot. They're at the same value. They have the same value at this point right here, right? So at this point only, the x value is the same for both lines, and the y value is the same for both lines. That's the only time where they're both at the same location. Does that make sense? So that's the only time where the y value is the same for this line and this line, and where the y value is the x value is the same for this line and this line. Yes? So, because I'm looking for when the y value is the same, I can say that, because this is y equal negative 2x plus 1 and y equals x plus 7. So I can say that y is equal to y, right? Because I know that y is going to be equal for both lines, okay? So if y is equal to y, then I can substitute this value in for y, right? So I replace the y and I put the value of y in it instead of it. So what happened here is, instead of writing y equal negative 2x plus 1, I write x plus 7 equals negative 2x plus 1. Okay? Does that make sense? It's called substitution. So I removed that y value and I substituted its actual value in the second equation in it. So I replaced it. Okay? That's right. So now you see that in this equation, I only have x and the numbers, right? I don't have any other letter, right? So what I can do is I can bring the x to this side and I can bring the 7 to this side, right? So I can have the x's on one side and the numbers on the other side. So that become x plus 2x equals to 1 minus 7, right? Because bringing the negative 2x becomes positive 2x. Bringing the 7 over, it becomes negative 7. Yes? Yes? All right. Then now I have like terms on the same side. So what's x plus 2x? X plus 2x? 3x equals 1 minus 7? Negative 6. And how do I isolate for the x? Divide by 3. So you're left with x equals negative 2. Okay? So I found the value for x, which is x equals negative 2. Now I want to know what the value of y is, because remember that my point of intersection has both x and y value. Okay? So because I know that x is equal to negative 2, I can replace that x equal to negative 2 into one of the equations. Okay? It doesn't matter which one, it's going to give you the same answer. So let's try. If I replace this x with negative 2, so that will be y equal negative 2 times negative 2 plus 1. What's negative 2 times negative 2?
4.
Plus 1. What is that? 5. So my y equals to 5. Okay? Let's try if it's going to give me the same answer in the second one. You don't have to do both of them, okay? So if I do negative 2 plus 7, that is 5. Yes? So y is matching for both, no matter which equation I choose. Okay? So what would be my point of intersection? What's the x value? What's the y value? And that's where the two lines are going to meet. Okay? So what I want you to do, before I'll give you time to copy this, let's try to use the graphing technique that we used yesterday. Okay? And let's see if we're going to get the same answer. So, where do I start for the first equation? It's negative 2x plus 1. Where do I start? I start at 1. That's my y-intercept. And then which way do I go? Down how much? 2 over... It's negative 2 over 1. So it's y equals negative 2x plus 1. So my y-intercept is at 1. My slope is negative 2 over 1. So I'm going to go down 2 over 1. That will be my next point. Down 2 over 1. Down 2 over 1. Yes? If I go up 2, I go to the left 1. How about the second equation? Where do I start? Where is the y-intercept?
1.
It's x plus 7. Where is the y-intercept? 7. So I start at 7. What does my slope tell me I have to do? My slope is 1. What does my slope tell me I have to do? Up 1 over 1, up 1 over 1, right? If I go down, I go to the left 1. Do you see my point of intersection? Do you see my point of intersection? Where is it at? Negative 2 and negative 2, 5. right? So graphing it proved to me also that my answer is right. But we can't graph every single time because sometimes my numbers are huge or they're far and then the point can be like somewhere in the middle of nowhere. So substitution might be a better solution, okay? So the steps for substitution are the following. First, if the equations are already isolated, like you guys have seen in this case where you have y equals something and y equals something, then what you have to do, you have to substitute one of the equations in for y. And then isolate for x. This is the whole idea behind it. Okay? So if you look at, let's say, question number 3 here, right? What would you do?
-2x plus 8 equals 2x or -7.
Yeah. So basically, you're going to replace this y with the negative 2x plus 8, right? So that's going to be negative 2x plus 8 equals to 2x minus 4. Okay? Then what do I do?
Would you move the negative 2x over to the right and then the negative 4 to the left?
Sure. You can do either way. You can bring the negative 2x over here and then bring the negative over here, or you can bring the 2x over to the left and then the 8 to the right. It doesn't matter which method you follow, as long as you know that you're doing the opposite operation. Okay? So if I want to bring the negative 2x, so if I want to bring this over here, right, and I want to bring the negative 4 over. So 8, negative 4, when you bring it over, it becomes plus 4 equals, I have the 2x. When I bring the negative 2x over, what does it become? Positive 2x. Okay? So I have 8 plus 4, which is 12, equals to 4x. Then what do I do? Divide by 4. So 12 divided by 4 is 3. So that means x equals to 3. Okay? Now if x equals to 3, how can you find y? Pick one of the equations, either 1 or 2, and plug the value of x in. Okay? So I'm going to pick the first one. So it's going to be y equals 2 times 3 minus 4. So 2 times 3, that is 6. Take away 4, so y equals to 2. Which tells me that my POI is x is 3 and y is 2. Okay? Now, sometimes, like in this case, we have x equals to this and x equals to 4y plus 42. Right? Yes, it's not y, it's x. Same thing. You're going to take the 4y plus 42, and then you're going to replace x with it. Okay? Because x is equal to 4y plus 42. So I'm replacing this x with 4y plus 42. You solve for y first, then you solve for x. It doesn't matter which one you solve for first. Do you want me to go over this one with you? So I replace this x with 4y plus 42 equals negative 3y minus 14. What do you want to do? Move the negative 3y over, and then move the 42 to the right. Okay? So that will be 4y plus 3y equals negative 14. When I move the 42 over, what does it become? Negative 42. Okay, what's 4y plus 3y? 7y. Equals negative 56. And then divide by 7. So that gives you, what's negative 56 over 7?
I don't do the right answer.
Why not? It will.
Negative what?
56 over 7.
Divided by 7?
Yep.
Negative 8.
Negative 8. Okay? So that gives you the y value. Okay? Now you're going to have to do the same thing. You're going to take that y value, and then you're going to plug it into one of the equations. Okay? So we'll do, let's say, we'll plug it into the second equation. So that will be x equals 4 times negative y plus 42. 4 times negative 8 is negative 32 plus 42. So that gives me negative or positive 10. So that means my x value is 10 and my y value is negative 8. So my POI is 10, negative 8. So as long as one of the letters is isolated, so x is isolated for both of them or y is isolated for both of them, I can do the substitution. Okay? I want you guys to try a couple of the questions before I go on with another, no, it will be another type. So what if I have this, for example, how would I isolate? How would I substitute? So I want you to try C and D. Okay, can you guys try C and D for me, please?